Alright, so these are the formulas for variance, and most of the time we're going to be looking at sample sets. We're not going to be looking at population. Now, most of the time, if you think about it, a population generally is a lot larger. So you'll see why you would have to be given a population standard deviation or variance rather than calculate it whenever we do some of these examples that we're going to go over today that just have a couple of numbers in it. And so if you imagine trying to do this with 100 data values or 1,000,000 data values, it just, it's just too much work to do by hand. So just to show you what I'm talking about, we're going to deal with a sample, and we're going to use this bottom formula right here to figure out the variance of this data set. So the data set is 16, 7, 7, 18, and 8. Alright. So the first thing that we need to do is figure out the mean. Alright, so we want to add all of those numbers together and then divide by what? 5. So what did you get our mean to be? X bar is equal to 11.2. Alright. So our formula is variance, this is sample variance, equals the sum of x sub I minus x bar squared divided by n minus 1. Alright, so what I suggest that you do is you make a column that is going to be x sub I minus x bar. Alright, and so I'm going to make a little table here. So it's going to help me keep things straight. And in my table, I'm going to put my data values, my 16, 7, 7, 18, and 8. And then in my next column here, so that's my x values. That's my x sub I values. So in the next column, I'm going to have 16 minus 11.2, what that's equal to. And then 7 minus 11.2 twice. 18 minus 11.2 and 8 minus 11.2. Alright, and so now what I'm going to do is I'm going to make another column and I'm going to label it x sub I minus x bar squared. So whatever answer that I got, I'm going to square it. So remember, when you square those, you're not going to have any negative numbers. These are all going to be positive. So I got 23.04. $17.64. 46.24 and 10.24. All right. Now for my formula, I need the sum of all of those. So I want to find the sum of these. So I need to add all those together. And it's really easy to mess up just one digit, so you got to be very careful. Alright, whenever I did that, I got 114.8. Okay. So now I have everything that I need to find the variance, the sample variance. So I'm just going to plug it in my formula. S squared, that stands for sample variance, it's going to equal 114.8 divided by n minus 1, where n is the number of data items that we have. So we have 5 data items, so I want to divide by 4. This is 5 minus 1. Alright, and so I have variance equals 28.7. Alright. Now, it did not ask me to find the standard deviation, it asked me to find the variance. And we have to be aware of that because a lot of times that variance answer will be down there. So we need to make sure if it says to find the variance that we find the variance, and then if it says to find the standard deviation, we do the same thing that we did. It's just at the very end we would take the square root. Alright, so that takes us to this next problem that says find the standard deviation, and it says round your answer to one more decimal place than is in the original set of data. Alright, so here is your set of data: 18, 18, 14, 11, 8, 8, 10, 17, and 12. 9 data items. And so since there is no decimal place, or we have a decimal place of 0, really, we want to round it to 1 decimal place. That's what it tells us to do. Alright, so the first thing we need to do is find the mean for this sample. So work this along with me to make sure that I don't mess up. Make sure you understand how to do it. And anytime you get a different answer, just tell me, because I'm human too. I make mistakes. Alright, so I summed all those up, and I got 116. Divide by 9. And did you get a mean of 12.8 repeating? Alright, so here's what I suggest doing. Since we're going to round our final answer to 1 decimal place, we need to carry this out a couple of places. We don't want to round this to, like, say 13. We don't want to round it to 12.9. We want to carry this out a couple of places, and that's because anytime you plug a rounded value in a formula, you create a margin of error. So I'm going to carry, since I'm going to round my last place to 1 digit, I'm going to carry this out to 3 digits, just so it'll cause less error whenever I calculate my final answer. Now, technically, we should have 12.8 repeating and plug that in every time. But, again, it's okay to just carry it out a couple of places. As long as you carry it 2 or 3 more places than what you're going to round at the end, it shouldn't cause that big of a margin of error. Let's see. We'll see. If our answer's not down there, then we messed up big time by rounding. So I'm just going to cut it off right there at 888. I'm not really rounding. I'm just cutting it off at 3 places. Alright, so I'm going to make one column. It's going to have all my data values. That's my x sub I values. Alright, I'm going to write these in here. and then I'm going to have another column just to kind of, the neater you are and the more organized your chart is, the less likely you are to make a mistake. So my next column is going to be x sub I minus x bar. So I'm going to say 18 minus 12.888. I'll do that twice. Alright, I'm just going to write all these down and then I'll actually start doing them in my calculator. I can at least do one or two of these in my head. The rest of these I'll probably punch in my calculator just to make sure. I just punched that in twice. Alright. So there's that column. My next column is going to be x sub I minus x bar squared. Again, remember when you square this, you shouldn't have any negative numbers after you square. And this is where more of a margin of error is going to come in, because when you square something, those decimal places start mattering a little bit more. I'm just going to take this one out to 4 decimal places just to be safe. Now I am creating a margin of error, but I'm creating it at the 10,000ths and 100,000ths place, so that shouldn't cause a problem in my final answer. I say shouldn't, but we'll see. We'll see if we needed to carry it out further whenever we get to the end, but I think we should be okay. No, you can't. When you square a number, you can't get a negative. Now, when you subtract, you get a negative, but whenever you square a number, you can't get a negative. And it may be that, if you punch it in your calculator without parentheses, then it'll keep the negative sign. So just imagine that the negative's not there if you get a negative answer. So now I need to find the sum of all of those.
I think you got one of those numbers wrong.
I probably did. Which one do you want
14.
me? Okay.
I got 1.2365.
All right. Let's see. 1.112 squared. 1.2. Yep. 365. So it's very easy to do. So sometimes you might want to do them all and then do them all again. But a data set this big, it is understandable that you do make a mistake here or there. Not just because I made a mistake. I make mistakes all the time. Alright, so after you add those up, see if you get this. See if I'm right, because again, it's easy to make a mistake. I got 130.8885. Okay, so that's the sum. That's not the answer to everything. That's just the sum of all of those squared. So now we want to follow the formula. Remember, first we find the variance, and then once we find the variance, we'll take the square root of that. So the formula is the sum of all of those squared divided by n minus 1. So it's going to be, the variance is equal to 130.8885 divided by n minus 1. There were 9 data items, so it's going to be divided by 8. Alright, so I have s squared equals 16.3610625. So I want to take the square root of that. Now some calculators are different as to how you can take the square root, so be careful. But I know in this TI calculator that I'm using, there's an ANS button. It's at the very bottom. It's in blue under the minus. It says ANS. What that will do is that will take your last answer. So if I do square root, that will be second and then x squared button. And then I do second and I hit the minus, it'll say square root ANS. So what that does is that'll take the square root of the last answer that you have in the calculator. Alright, if you hit equals, or you just plug in that whole number and take the square root, and I got 4.044881024. Alright, so if we rounded that to 1 decimal place, that's 1 more than the original set of data. Then what would my answer be? What would S, that is sample standard deviation, be equal to? 4.0. That's the answer. So you always have to make sure that you refer back to your directions to see what decimal place that you want to round to. And then whatever decimal place you want to round to, it's kind of standard to do 1 more than the data set. I've done that a lot over the years, though sometimes directions may tell you to do something different. So just make sure that whenever you have these intermediate values, that means these values that I'm using in the formulas, you carry those out several places. Let's do the next example that I have here has only 6 data values, so that's a good thing. but there's a decimal here. So that's kind of, not that that's a bad thing, it's just we're starting out with decimals. Okay, so let's look at this next example. This next example, the data values are 24.4.
Is this a sample variance or a sample?
This is a standard deviation again. So 24.4, 11.8, 38.9, 29.7, 11.2, and 14.6. All right, so we're going to find the sample standard deviation, which is the square root of the variance. So you have to find the variance to find the sample standard deviation, unless you use a different formula. So first we need to find the mean. That's step one. When I added those together, I got 130.6, and then divide that by 6. Alright, so I'm going to carry this out several places. Now, it says to round one more digit than the original set of data. So we're going to have to round to the hundredths place here. So since we're going to round to the hundredths place, I'm going to carry it out 2 more digits, just so I can be a little more accurate with my calculations. So this is going to be 21.7666. If you don't want to use 666, use 667. It'll probably still come out okay. Alright. If you're superstitious or that bothers you. So let's see. So now we need to take and make one column that is x bar or x sub I minus x bar. I'm also going to write down my data items or data values one time in a column, just so I can try to keep things as neat as possible. That way if I do make a mistake, it'll be easy to come back and figure out where I made the mistake, because I'll have everything written down that I'm using. Okay, so there's my 6 data items. Now I'm going to write down what I'm doing. I'm going to say the data item minus the sample mean. Probably need a little bit more room. Oop, I put it in the wrong spot. Sorry about that. So my next column is going to be x sub I minus x bar squared. Remember, all of these will be positive. Alright, so I carried that out a little bit further. I'm worried about my rounding error. If you can think back to maybe a time when you've done a lab in chemistry and you have a margin of error and then you're like way off, it's really because, you know, us humans, we can only measure things to some, you know, to 1 decimal or 2 decimals or something like that. So unless you have equipment that's very precise, you're going to have a margin of error. All right, so let me add those values together. And it's very easy to mess up on a decimal. So if we don't get the right answer, we'll just come back and figure out where we made our mistake. But we should be pretty close. Alright, so when I added those up, I got the sum equal to 625.77331. We'll know soon if I messed up. Because now I'm going to plug this into the variance formula. Remember, that's s squared equals, and then it's a sum of all of your x sub I minus x bar squared terms divided by n minus 1. So there were 6 data items. So 6 minus 1 is 5. Okay? So whenever I did that, I got the variance to be 125.154662. So if I take the square root of that, so that's going to be square root, and I got s squared equals 11.18725. So if I round that to 2 decimal places, because the direction said 1 more decimal place than the original set of data, then I can find my standard deviation is about 11.19. All right. Any questions? It's a lot of calculations, and there's a lot of room for error. Okay, there really is. So you have to be very careful with your calculations. And the more data values that there are, the more room for error there is. So again, you got to be careful. Now, the next term that we're going to go over is one that you may be familiar with. It's the range. And so the way that you find the range, that's going to be the difference between the largest and smallest data value. So what if I wanted to go back to that data set that I was just working with on the example 3 there, and I wanted to find the range? So I would take the biggest number, that's 38.9, and then I would take the smallest number, 11.2, and I'd find the difference. So the range is 27.7. The largest data item minus the smallest data item. Now, before we go too far away from standard deviation and we do some other things, I do want to introduce the coefficient of variation. Now, that is skipping to section 4.8. But I want to go ahead and go over it because it is related to what we're doing now, what we've been doing with standard deviation. Okay? So the coefficient of variation, we'll go back because we did skip several sections, but the coefficient of variation is another statistical measure, and what it does is it compares the variation in different data sets. So if you have 2 data sets, you can compare the variation in the 2 data sets. So coefficient of variation is abbreviated CV. If you see CV, we're talking about coefficient of variation. And the way that you get that is you take the standard deviation, divide by the mean, and say that times 100, and you'll get a percentage. Okay? So you know how we found the standard deviation earlier? Well, we would have to do that for both sets. Then I would find the mean of the first set, and I would find the mean of the second set, and I would say the standard deviation of the first set divided by the mean of the first set times 100. That would give me a percentage, coefficient of variation. Then I would do the same thing for the second set, and I'd have 2 percentages. Now, the group with the largest variation, you could then say would be the one with the largest percentage. So here's an example, and this deals with something that some of you will definitely be dealing with in the future. The problem lists 2 sets of systolic blood pressures. We have one data set that is for men aged 20 to 29. And so that data set is 117, 125, 133, 118, 131, and 123. Okay, and then we have another data set that is for men aged 60 to 69. And you would think, you know, older men are probably going to have higher blood pressure, right? So these should be a little higher, maybe, some of them, depending on if they took care of themselves. Or sometimes it's just hereditary, no matter what you do. Okay, so we're going to find the coefficient of variation for each of the two data sets. And then we're going to compare their variation. And we'll be able to tell which group has more variation by doing that. It's just a way, because think about it, if you have different data sets and you're trying to compare one data set to another data set, there has to be some way to compare the two, and there is, and it's by using the coefficient of variation. It makes one data set relative to the other data set. Like, I can't say, you know, that I could say something like, okay, if you're 6'10" and you're a man, then relatively you are taller to everyone else. But it wouldn't be fair for me to say that you would have to be 6'10" as a woman to be relatively tall to every other woman, would it? Someone that's maybe 6'5" or 6'4" as a woman would be relatively taller than any other women. So, you know, because the heights of men overall, not always, but overall, are taller or larger than the heights of women. So we want to look at things relatively. So to do that, that's why we find a mean for each data set, and that's why we find a standard deviation for each data set, and then we can come up with a coefficient of variation that will help you relate one data set to the other. All right. So I'm going to start with the first data set for the 20 to 29. And I'm going to list those data values. Now these numbers are going to get big, and they're going to get big fast because whenever we start squaring them, you know, numbers get pretty big because we're saying that number times itself, and we're in the hundreds already. So just know that these numbers are going to be pretty big. And just to save a little time, I'm going to punch these in and square it and then put the number down. So we're just going to do this one row, this column like that to save time. Now first I need to find the mean. So did you get the mean for the first set to be 124.5? Okay, so what I'm going to do in my calculator, I'm going to say 117 minus 124.5, and then I'm going to square that answer. It'll just save me a step. I guess the numbers aren't going to be too bad, at least not right now. So that's good. They're all close to the mean. If they weren't close to the mean, it would be a lot worse. I made a typo here. That's not one. It wasn't 223. It was 123. That would have been bad. That was the very last one there. Alright, so we'll sum those up. And when I sum those up, I got 215.5. So S squared is going to equal to 215.5 divided by n minus 1 is going to be 5. So I have the variance is 43.1. Now don't forget, we have to take and find the standard deviation. And so I'm going to round the standard deviation to one more than the data set. Data set didn't have any, so I'll just round it to, I tell you, that just makes me uncomfortable to round it that far. I'm going to round it to 3 places just because. And so you say, how would you know? Well, if you're ever in doubt, it says to round the result to 1 decimal place. So I would at least carry this out to 2 decimal places. But since I'm kind of nervous, I'm going to carry it out to 3 decimal places. And then I'll round my final answer to 1 decimal place like it asked me to. So the way that I can find the coefficient of variation here is the coefficient of variation is equal to the standard deviation divided by the mean. And then we say that times 100. So alright, so if I round this to 1 decimal place, I'll go ahead and I'll write down here's what my answer was. But if I round that to 1 decimal place, my coefficient of variation will be equal to 5.3%. Alright. So that's the coefficient of variation for the first group. So now let's do the same thing for the second group. So I'm going to write down those values. This is 60 to 69 aged men. Write down those in a column. So that's 130, 151, 138, 125, 164. It's more like my blood pressure there. And 139. So we need to find the mean for this data set. So we can't use the same mean, it's a different data set. So I got the mean as 141.166. Anybody else get that? 141.166, and it is 6 repeating, but I'm gonna stop it right there. If you want to put a 7 there, that'll be okay. I'm just gonna carry it out a couple places. And then remember this next column, I'm gonna kind of do a shortcut here. I'm gonna say the x value minus the mean and then square it and put that down here. now I need to find the sum of all of these. Alright, so when I sum these up, I got 1019.101.
On the 125, I got 261.3395.
Okay, so this was 3395? Okay. So that would change this a little bit. What'd you get for the sum? Let's see. I got 1019.0425. Anybody get that? If you didn't get that, I'll do it again. I'm gonna do it one more time just to check my answer. You said 3395 there?
Yes, sir.
Okay. Alright, I added it up again. I got the same, wait, I got 045. Instead of 0425, I got 045. Did I mess up? Did anybody get 0425? Alright, that's a good thing. We need to check all of them, then, I guess. So on 130, I messed up on the first one. I can tell that I messed up on, well, I don't know. Let's see. 130 minus 141.166 squared equal, oh, I messed up. 130 minus 141.166 squared. It's supposed to be 124.6795. Oh, 138. All right, 138 minus 141.166 squared. So I got 10.023. Yeah. So 138 minus 141.166 squared. That's what I got. I think that if we're just off by like a tenth or a thousandth, it's not going to matter anyway. But it is good to go back through and make any, if you do make a little mistake like that, it's good to go through and maybe work it out twice if you have the time. That way you'd be able to tell if you messed up. I'm going to do this one last time and then we'll finish this problem. That time, unless I fat fingered a number like I can do, I got 118.8365. Okay. One other person got it. I'm going to stick with it. Alright, so let's find the variance. So the variance is that divided by n minus 1, which is 5. So the variance is 203.6773. So the standard deviation is 14.2747. And then let's take that and let's find the coefficient of variation by taking the standard deviation and dividing that by the mean and saying that times 100. And I got 10.112 blah blah blah. So percentage. So if we want to round that to 1%, you see sometimes if we messed up out here on the 10,000ths, or it's probably not going to affect our final answer. So that would be 10.1%. So if we look at those two sets of data now, we can tell that the second set of data varies more. Okay, it has a larger relative variation than the other set of data. The second set of data does. So I would think that, as you get older, some men take better care of themselves than others. And again, it could be hereditary that you have different things, but the more exercise you do and the better that you take care of yourself, but as you get older, there's more men probably that don't do exercise. Some do, some don't. So that would probably account for the wider variation that you have. Again, that's called coefficient of variation, and you won't have homework on that until 3.8, but it is closely related to standard deviation, so I wanted to make sure that I went over it then.